Well, hello, my wonderful people, and welcome to the wonderful world of the experimental method. I am sure that you are so excited for another dive into research methods on your online learning time, and very excited to speak with you in this particular session about the only type of method that allows us to claim a cause and effect relationship between variables, the experimental method. So, before we dive into the fun together, just wanted to remind you that you should definitely have your interactive notebook out and ready and open to section 4, the experimental method. So these exact words are printed in your interactive notebook in that green area. Okay, so last time we were together, we learned about different types of research methods that psychologists can use to test their ideas empirically. And so we talked about how all psychologists go through the 5 steps of the scientific method. There's just different approaches that we can choose based on the types of questions that we're trying to answer. And each of those approaches has some pretty unique pros and cons. So last time, if you remember, we talked about surveys, naturalistic observation, case studies, and correlation. And all of those have really valuable uses, but none of them allow us to claim a cause and effect relationship between variables. And so today we're going to spend some time looking at the true experiment or the experimental method, which does allow us to do so. And there's a lot of vocabulary involved with this particular method, and it's absolutely going to be worth your while to really dig in for this particular section of material because it's going to be threaded again and again throughout every chapter that we look at together. And the reason being, and here's why this is really important, and hopefully you'll feel really valuable to learn for yourself, is that it's really easily, I think, in society for people to be manipulated by psychological research, educational research, you name it, people can be manipulated by it. And so it's really important to have a strong understanding of exactly how experiments are designed and implemented and the way that results are analyzed so that you can be sure that if somebody's telling you something is research proven effective, that they're not actually just um, teasing you or trying to convince you in the direction that they want you to believe, but rather that they're actually providing you with sound results. So, always good to be critical consumers of information. And that is our goal today when it comes to understanding the true experiment or the experimental method. So, again, diving into the fun here together. The only research method for investigating cause and effect relationships, aka causation, aka you'll sometimes hear people say there's a causal relationship between two variables. The only way to do that is the experimental method, or sometimes it's called the true experiment. Okay, and this is possible because the true experiment or the experimental method enables the researcher to manipulate one variable in question and observe the effect of that manipulation on one or more other variables while controlling for every other possible thing that could impact the results that we're looking for. So we say we isolate the effect of one variable on another, and that's why we're allowed to claim that one does in fact cause a change in the other. Okay, we talked about some pros and cons of each method in class last time. The one con about the experimental method is that it's criticized for being too artificial to assess a lot of behaviors that most people usually exhibit in life because it's impossible to replicate real life exactly in a lab setting. So, for instance, last time when we talked about naturalistic observation, we said that if I want to observe how preschool children actually make friends with each other, I'm going to go to a real setting where they actually do such things. And if I tried to bring them into a lab and design some artificial activity for them to go through, I'm really not going to get very authentic results. My results would be artificial because the situation would be too artificial. So, the big pro of this method is that it can establish cause and effect relationships. The drawback is that it can be artificial. So, we only want to use this method when we're trying to establish a cause and effect relationship between variables. Okay, so as a reminder here, Just like in the other approaches we looked at last time, all good research begins with a hypothesis. Last time, we said that a hypothesis is basically a testable description about the expected outcome of a study. And we said that a good hypothesis should always really explain what you expect to happen. It should be clear and understandable. It should be testable and measurable, and it should contain the variables that you're interested in studying. So here are two great examples. Number one, if participants drink a 12-ounce cup of coffee before working on a puzzle, then they finish the puzzle faster than those who did not drink coffee. They're probably trying to test a hypothesis about the impact of caffeine on attention or something like that. And then another example from sports psychology, if people eat protein, then they run faster. That's a testable hypothesis as well. Let's say that I do want to establish a cause and effect relationship between variables. And let's say that I'm operating under a working hypothesis. You can kind of see the middle box there under where it says example. Let's say that my hypothesis is that children with ADHD who consume less sugar will have improved attention. Okay, if I want to figure that out and I want to show that changes in the amount of sugar in someone's diet can actually impact their ability to pay attention, then I can do a true experiment to test for that. So let's look at what that looks like through this ongoing example. And here we're going to incorporate a lot of really important terms related to the true experiment. Highly recommend that you jot down your own definition. What do these terms mean to you? Because that's going to help you remember them better, and try to put some examples next to your definition so that not only when you go back to study do you remember the definition, but also what does this actually look like in real life, okay? All right, quick note before we dive into that experimental terminology. A really, really important concept that you're going to learn about in this chapter that extends beyond this chapter into the rest of the course is that, remember, a true experiment is the only type of experiment that allows us to claim a cause and effect relationship between variables. Very often, students confuse correlation for causation, okay? So remember that a correlational study, we learned about this last time, can help us understand that a relationship exists between two variables, but we cannot say that just because a relationship exists, that cause and effect can be inferred. So just remember that. So thinking about the example we just looked at with sugar and attention, there definitely could be a relationship. There definitely could be a correlation between those two variables. And I want you to think for a second about what is the direction of that relationship, sugar and attention. Would that be a positive relationship or would that be an inverse relationship, do you think? Think about that for a second. It quite likely would be an inverse relationship, right? As the amount of sugar we consume increases, it's probably likely that our ability to pay focused attention decreases. So those move in opposite directions, and we would expect to see a negative R value then. Okay, all right, so let's dive into our experiments here. Again, in an experiment, we can isolate cause and effect because we're manipulating our factors of interest, our variables, and we're holding constant any other factor that could influence what we're studying. So let's see how that works. Okay, in a true experiment, we always have two types of variables. An independent variable is something that we as the researcher are going to manipulate, and it stands alone. It is independent of any other variables. Okay, so in this particular example that we're looking at, sugar would be considered our independent variable. I, as the researcher, can manipulate the amount of sugar that participants in my study get, and then we can look at the impact that those varying amounts of sugar have on attention. Okay, in this example, we also have a dependent variable. A dependent variable is whatever we're looking to measure in a true experiment, okay? And I always remember this by telling myself that the dependent variable, the dependent measure, is always dependent upon the independent variable. Okay, in our case, the dependent variable would be attention span in whatever way we decide to operationally define that. Okay, so if we wanted to test the effects of varying amounts of sugar, the independent variable, on attention span, the dependent variable, then we could definitely do that. As a reminder, especially in true experiments, we always have to be really careful to operationally define our variables. Both our independent and dependent variable need to be articulated in a way that's very precise and concrete and measurable. Okay, so thinking about an operational definition for sugar, we would want to include details such as how many grams of sugar are these people going to eat per day? How often per day are they going to have this sugar? And other types of things like that. What type of sugar, the quality of sugar, where is it coming from? Is it coming from fruit or candy? Or all of those things would go into our operational definition for the independent variable, which is the level of sugar. Okay. For the dependent variable, when we're looking at attention, we could define this a number of different ways. We just have to decide and say what our operational definition is. So we might say that we're going to measure the number of sustained minutes that our participants can pay attention to a particular task. And maybe that's our operational definition of attention. Okay, so we have our independent variable, the one that we're manipulating. We have our dependent variable, the one that we're measuring, and it depends on what we do with the independent variable. We also have to be really careful in looking at potential confounding variables in a study, okay? And a confounding variable, it's any other factor or variable that might influence what we're trying to measure other than our independent variable. Because if you remember, when we try to establish cause and effect, we're saying as the experimenter that I am isolating the effects of sugar on attention. Everything else I'm holding constant. So if attention changes, it can only be because of the amount of sugar that my participants took in. So I want you to think for a second about this experiment that we're conducting, my friends. So we're giving people different amounts of sugar, and then we're measuring their attention. And let's say that we're measuring their attention by the number of sustained minutes that they can pay attention to a particular task. What other things in real life, in our experiment, might influence people's ability to pay attention other than the amount of sugar that they ate? Think about that for a second and try to come up with 2 or 3 things. Okay, any number of things could influence someone's sustained attention, right? So if you didn't get enough sleep the night before, your attention might be worse than somebody who did if you didn't eat a good breakfast. If you think the task is super boring and you don't care, if the room's too cold, if the room's too hot, there's tons of factors that could influence the number of minutes that we can pay attention to something. And so if I'm trying to claim a cause and effect relationship between sugar and the dependent variable, I have to control for every other confounding variable. All the examples I just gave you would be examples of things that could influence the measure that I'm interested in that I didn't control for. So I have to control for those or my experiment's not valid. Really important. Okay, so once we kind of design the backbone for the experiment itself, now we have to figure out who's going to be in our study. And so here's some really important vocab related to the participants in your particular study. The idea behind doing a true experiment is that you're going to do a test on a smaller subset of whatever population of folks that you want to generalize the results back to. Okay, so in our example, we're talking about children who have ADHD. We want to do an experiment to inform this particular population. Okay, so in our case, the population, which is the set of all the individuals of interest in a particular study, our population would be all children in the whole wide world who happen to have ADHD. We're doing a study to try to help out that population. Obviously, it is not feasible for us in our own experiment to test every single child with ADHD in the entire world as part of our experiment. And instead, then, we want to draw a sample from the larger population. A sample is a subset selected from the larger population. And the idea is that we want to select that sample in a way in which the sample is representative and random. Okay, so we want to randomly select a sample that's going to be as representative as possible from the population that we drew it from. How do we do that? Okay, so we start out with a population. We say our population is all children with ADHD. Now we need to figure out how can we reasonably select a subsection of that population that's going to be able to take part in our study. We want to do that randomly so that there's no bias involved in the way that we select the sample. So we'll talk more about that in a minute. Once we get the sample, then we're going to also randomly split the sample into our experimental or our treatment group and our control group. So let's dig into that a little bit more. Okay, so we have a population. Now we want to draw our subset from the larger population, and we're going to do that randomly. Random sample is a hugely important term, and when you sample randomly, it basically just means that you're choosing members to be in your study from the larger population in such a way that every member has an equal chance of being selected. It's basically just saying that you can't go around and hand pick any child with ADHD that you want to be in your study. Instead, you have to do it systematically and randomly. And the reason that we do that is when we do random sampling from the larger population, this eliminates bias and it helps us get a representative sample. A representative sample means that the people that are taking part in your study actually mirror the larger population on any important characteristic that might impact your results. So we would want gender to be kind of similar. We would want ethnicity to be kind of similar. We would want age to be kind of similar, because the idea is that the results from the experiment that we do, we want to generalize those back to the larger population. We want to be able to say the findings that we have with this subset of the population actually hold true for all members of the larger population. But in order for us to claim that, the sample has to be random and representative. Okay. All right, so again, how do we make sure once we have our sample that's going to take part in our experiment, how do we make sure then that there's no bias in the way that we randomly assign the sample to groups? So we have random sampling, which means taking people from the larger population to be part of your study. Once we have those people, now we're going to talk about random assignment. Once we have them, we have to randomly assign them to the experimental and the control group. Again, when I get my sample, I don't get to just decide as the experimenter, well, I want all these kids to go into the treatment group, the experimental group, and I want all these other kids to go into the control group. Why can't I do that? Probably because I might have some bias in some way as the experimenter. And what if I think that the less sugar you eat, the better your attention span is? That's my hypothesis, right? So what if I put all of the students that naturally have the best attention span into the experimental group? They're going to outperform the control group, whether they ate a lot of sugar or not. And now I have completely biased results that aren't going to hold up. So to protect against experimenter bias in particular, we always want to do random assignment to groups. And typically when you do random assignment, you make sure that each group is relatively equal on every major factor that might be impacting the measure that you're looking to find, that dependent measure. Okay, so let's talk about groups for a second. In a true experiment, there's always at least two groups. There's the experimental group, which receives the treatment or the independent variable dosage that you're interested in. And then we always have to have a control group that doesn't receive the treatment. And why would we have to do that? The control group serves as a comparison group, typically to guard against something called the placebo effect. Okay, so the placebo effect is an experimental effect that's actually caused by expectations about what an intervention is going to do and not the intervention itself. So said another way, the placebo effect is something where if I, as a human being, think that a particular intervention is going to have a certain result, I can actually think that into becoming true. And you guys, there are so many remarkable examples of the placebo effect. I remember in college, I was taking a health psychology class, and our professor talked about how she was doing a study where they were looking at male pattern baldness, and they were trying to find a pill that would allow you to grow hair if you had male pattern baldness. And they told the control group in this particular study, yeah, this pill that we give you, it's going to generate so much hair growth, you're not even going to believe it. But really, they just give the participants a sugar pill. There's nothing of value in it whatsoever. And those people grew hair. Just them thinking that the pill was going to make them grow hair, they grew all this hair. So the placebo effect is super strong and powerful, and we have to make sure that we have a control group, a comparison group, so that if the experimental group does in fact make gains in the direction we're interested in, we know that they were actually the result of the treatment itself and not just the placebo effect. Okay. So we just talked about how when you have an experimental group and a control group, very often, whenever possible, you want to give your control group some sort of placebo. It's basically just an inactive substance or other fake treatment in place of the experimental treatment itself. And we'll see this play out in a couple examples that we're going to do in just a minute. But the example that I just gave you was an example of a placebo. So in the male pattern baldness study, the experimental group received a pill that actually had chemicals that were supposed to grow hair on your head. And the placebo group, the control group got a placebo. And again, it just was a sugar pill. They said that it was going to grow hair, but it was just sugar. Okay. In order for this to have the least potential for bias, the control group is typically blind to whether they're receiving the real or the fake treatment. And that's called a single blind study. So again, the idea is in a true experiment, the participants have no idea whether they've been assigned to the experimental group or the control group. Only you as the researcher know that, because we want to guard against the placebo effect. We want to really see what's happening. So again, a single blind study is when participants are blind as to whether they are in the experimental group or the control group. If there are instances where you think you might get accused as a researcher of having a bias or really a high investment in wanting the results to turn out a certain way, then you should also arrange to do a double-blind study. And in a double-blind study, neither the participants nor the research staff that are implementing the experiment know which participants are in the experimental or control group. So there's no way that anybody can unconsciously impact the results of the experiment. And what you do instead then is you hire an independent team to come through and analyze the results for you so that there's no possible bias that's going to be, impacting the true results that you're looking for. Okay, so that was a lot of terminology. What we're going to do now is we're going to take some time to just practice applying all of these terms to some different real life situations. And we tried to pick different situations that would be interesting to all of you for different reasons. All right, so what we're going to do here, in just a minute, you're going to pause the video and you're going to have a chance to try to identify these key terms related to true experiments in 4 different true experiments. Okay, so in each of these scenarios in your interactive notebook, you're going to identify the following elements of experiments: the population, so all of the individuals who could potentially participate in the experiment and to whom we want to generalize the results back; the sample, which is the subgroup of people that we're going to get to participate in the experiment. Remember, we always want to randomly select that sample so that it represents the larger population. You're going to identify the independent variable. So what is the researcher manipulating? And the dependent variable, what is the researcher looking to measure? You're also going to identify what treatment does the experimental group get, and how are we going to treat the control group? Are they going to get a placebo? What's going to happen to the control group? So you're going to write that down as well. And then you can also write down any possible operational definitions that might hold true for these various scenarios. Okay, so example number 1 here has to do with depression. All right, so there's 100 individuals with moderate depression. 50 receive 8 weeks of a new cognitive behavioral therapy treatment, while the other 50 are placed on a waiting list for 8 weeks. After 8 weeks, all 100 are given psychological tests to assess their level of depression. So in a moment, you're going to pause the video and I want you to write down, what is the population? What's the sample? What's the independent variable and the dependent variable? Where it says EG, list the treatment that the experimental group is getting. And where it says control group, CG, list the placebo. And tell me some possible operational definitions there. So go ahead and pause and try that one. All right, so coming back together, in this case, the population is all people who are struggling with moderate depression. In our case, it looks like we've randomly selected a sample of 100 individuals with moderate depression, and now we've randomly assigned 50 individuals to receive the independent variable in the experimental group, and 50 individuals to receive the placebo in the control group. Okay, so our independent variable in this case is therapy. So the experimental group is getting therapy for 8 weeks, while the control group is not getting any therapy, but they've been put on a wait list. Okay, and the dependent variable then is the level of depression. And they mentioned in this example that they're going to do a test for depression, a psychological test for depression. So that's the operational definition for that. And then when we look at the independent variable, the operational definition is an 8-week duration of treatment or no treatment, depending on whether they're in the experimental or the control group. Okay, let's try another one. So number 2, a biopsychologist is studying the effects of anabolic steroids on the aggressive behavior of female rats. 24 female rats received daily injections of a placebo or a fake drug, while 24 others received daily injections of the steroid. Round-the-clock videotapes of the communal cages of all rats allow all aggressive encounters to be counted and timed. So go ahead and pause the video and fill in the information here for these angry rats. All right, coming back together. And again, we're probably studying rats here because this experiment is not ethical to do on humans. Can you even imagine? And so they probably want to generalize to humans, which actually is appropriate sometimes, especially if the procedures that we're looking at are in parts of the brain that we share with those lower level animals. So anyhow, our population is a whole bunch of rats. Our sample is 48 rats in particular. We have randomly selected that sample, and now we are going to randomly assign these 48 rats into the into the experimental group and the control group, okay? The independent variable here is an anabolic steroid. And so the experimental group gets the anabolic steroid, while the control group gets a fake drug or a placebo, again, because they're the comparison group. Okay, the experimental group gets daily injections of the drug, the control group gets daily injections of the placebo, so there's our operational definitions for the independent variable. And the dependent variable, it looks like they're going to be doing an observational study of aggressive behavior, where they're probably going to be tallying instances of aggressive behavior like bites or clawing or something else like that. And they can define that however they want, as long as they define it and measure it consistently. All right, 2 more. Let's try 2 more. Number three, all of you folks who want to go into business and you're interested in psychology, you can actually make an amazing living being an industrial organizational psychologist. And this is where businesses will hire you as a consultant to come in and look for conditions that are going to increase their productivity. It's really fun, really lucrative career. So an industrial psychologist is interested in whether lowering the temperature in a packing room will increase productivity, the number of products packed. Workers in 2 equivalent packing rooms participate in the study. One room is maintained at 65 degrees. The other room is left at the usual company temperature of 76 degrees. So in this case, go ahead and pause and practice on your own. And then coming back together here, our population is workers. And our sample in this particular case is whatever workers in this particular building or company that they got to participate in this experiment. So this would not be considered a random sample. It probably was a volunteer or opportunity sample, so not truly random. So we have to be careful about the results. And then they split these workers into the experimental group and the control group. The independent variable in this case is room temperature. And what we're interested in looking at is the impact of lowered temperature. So the independent variable, the treatment, is the lower temperature, 65 degrees. And then the control group is just keeping the room at the normal temperature, which is 76 degrees. Okay. And then our possible operational definitions here, the temperature measure is really straightforward. And then the dependent variable, they're measuring productivity really specifically in terms of the number of products that are packed during a particular time in which they're in the room with these particular temperatures. Okay, last one here, number 4. So big pharma drug company is conducting research of their new drug, Attendomax, to improve the note-taking behavior of college students diagnosed with ADHD. 50 of the students received capsules that contain the drug. Another 50 received capsules that look the same but contain a placebo or a sugar pill. All students attend the same series of lectures and have their notes collected afterwards. Notes are scored for completeness and accuracy. So our population is college students with ADHD. We're going to randomly select college students with ADHD from the larger population. We're going to split half and half into the experimental and the control group. The independent variable, the experimental group is going to receive that drug. The control group is going to receive a placebo. Our operational definitions here, so the drug measure is very straightforward for the independent variable. For the dependent variable, they're looking at note-taking behavior, and they are defining that as note completeness and accuracy. All right, so hopefully those examples were helpful for you in terms of applying this research terminology to some real world examples, and we'll be sure to review all of this together in class as well. Thank you so much for putting in the mental effort to understand those terms and apply them to real life. I really do promise you that effort is going to pay you dividends moving forward in the future, in that you're going to be a really well-informed, responsible, critical consumer of information, which sadly so many people in our world are not. So good for you. Okay, last little thing we're going to do together online here is think about how research design drives the conclusions that we can draw, again, based on the type of research that we're doing, as this applies to the true experiment. So as a reminder, the true experiment is the only type of design that allows us to determine cause and effect, because we can control variables that we're interested in and limit confounding variables, so we can really isolate the effect of the independent variable on the dependent variable, and that helps us establish clear causation. Okay, the use of experimental controls reduces alternative explanations, especially because we can compare our experimental group to a control group. And this allows for high internal validity. So internal validity is the degree of confidence we have that the causal relationship we're testing is not influenced by any other factors or variables. We get to claim that high internal validity again because we're controlling for all of those potential confounding variables, and we're really isolating the impact of the independent variable on the dependent variable. Okay, and just one final clarification. I've noticed that it's really common for students to confuse random sampling from random assignment. So just want to go over that one more time. So random sampling has to do with getting our participants from the larger population. We want to select them randomly so that the sample that we get represents the larger population on important characteristics. Once we have them in our study, now we talk about randomly assigning them either to the experimental group or the control group. And specifically, we engage in random assignment to decrease the likelihood that experimenter bias or any other confounding variable is going to influence the measure that we're looking for, that dependent variable measure. Okay, so just one last look at the experimental design overall. We always start with a hypothesis, an if-then statement. We then decide who our population is. We want to randomly select our participants from the larger population. We then want to randomly assign them into either the experimental group who gets the independent variable or the control group who gets the placebo or nothing, the control group. And then we're going to measure the dependent variable. The dependent variable is always the same in both groups. You're measuring the same thing about participants in the experimental or the control group, and you're looking for differences between the experimental and the control group on that dependent variable measure. And if you find a significant difference, then you get to say, hey, I think that what I did with this independent variable caused this change in the dependent variable. Therefore, whatever the independent variable is caused this effect, and you get to say that in your results. And hooray for you. Okay. Little bit of a highlight into our class next time. We're going to talk a little bit about statistics and sampling and generalizing back to the larger population. I just want to throw this term out for your consideration, and we'll unpack it a little bit more next time. There is the potential for sampling bias, which again is why we need to try our best to get a random sample when we're picking people from the larger population. So sampling bias is a result of a flawed sampling process that produces an unrepresentative sample. Sometimes when you're trying to do an experiment, it's literally impossible to get a totally random sample. And so you just have to do your best and work with the participants who are willing to work with you. So sometimes psychologists will engage in volunteer sampling, where they're just choosing people into their study who have volunteered to do so. That might not be the best result because something about the people who volunteered to participate might make them fundamentally different than the population we're trying to refer back to. Opportunity sampling is literally just picking people around you, whether they kind of want to do the experiment or not, but they're just around and they're kind of willing to do it. And so you choose them because they're quick and economical. That's not always the best either. So just wanted to put those out there for your consideration, and we'll unpack those a little bit more in class next time. Thank you again for your amazing attention as we learned about the true experiment together today.